In this video, we're going to learn how to compute the derivative of a constant function. So we have a function f of x equals c, where c is just some fixed number. And we're going to start things out just by using our geometric intuition here. There's a picture of a constant function. It just has the exact same y value no matter what x you plug into it. This gives us a horizontal line, and we know the slope of a horizontal line is always 0. So we immediately conclude the derivative of a constant is 0. Now we can back this up by actually doing a calculation with the limit definition of the derivative. So there's the general definition of the derivative of f of x. The limit as h goes to 0 of f of x plus h minus f of x all divided by h. And I'll post a link to the video where this was first derived by looking at the slopes of secant lines on an interval whose width was shrinking. So now all we have to do is evaluate this limit for the specific function that we're looking at, which is f of x equals c, this constant function. And again, this is a function that just gives you an output of c no matter what you plug in for x. So f of x plus h is just going to be c, and f of x is going to be c. And we're dividing this by h. So that numerator simplifies to 0. And now we have the limit as h goes to 0 of 0 divided by h. And I got some really interesting questions from my students on this, asking basically, isn't this an indeterminate form, 0 over 0? And don't we have to do something algebraically to work around that? And the answer is no in this case, because that numerator is exactly 0, while the denominator is just approaching 0. And that means the next step here to get clarity on this limit is to say the thing inside the limit is exactly 0. If we take 0 and divide by something small, we still get exactly 0. Now I know the limit of a constant is just the value of that constant, so this limit turns out to be 0. So there's the derivative of our constant function. In other words, the slope of a constant function is 0 for any value of x. Now it's useful to use Liebniz notation to wrap this all up in a simple statement. So I'm going to write d dx of c, in other words, the derivative of c, is equal to 0. So now anytime we find ourselves differentiating a constant as part of a larger problem, we immediately say the derivative of a constant is 0. In the next video, we're going to learn how to differentiate power functions. In other words, functions of the form x to the n. I've posted a link to that video at the upper left of the end screen and a link to my derivative playlist at the lower left of the end screen, and I'll see you there.